Okay, next we're going to have a look at topic 2.4, so which is called as techniques of graphing. So for topic number 2.4, what we're going to do is we're going to sketch a graph of various type of functions. So we have done the sketching before, but now what we're going to do is we're going to transform the graph of functions. Okay, so what happened is that, so let's say our original function, so original function is going to be in term of f of x. So if we were to transform it to become a function of negative f of x, so what happened is that, so the graph is supposed to be reflected over the x-axis. So what does it mean? Okay, let me put that smaller. So when you have f of x to negative of f of x, so your graph is supposed to be reflected over the x-axis. So example of this is, for example, let's say if I have a graph of f of x is equal x plus 1. So let's sketch f of x equal x plus 1. So let's say this is going to be my axis. So the intercept value is going to be somewhere at the value of 1. So let's say this is going to be my graph. So it's going to look something like this. So that is going to be a graph of f of x equal x plus 1. So when I transform the function to negative of f(x), meaning that I'm going to have to negative the whole function, okay? So this transformation is going to be like this. So here, so negative of the function f of x is going to be negative of this whole function over here, so which is going to be x plus 1, and I'll end up with a negative x minus 1. So that will be the outcome of that. So here what happened is that, so what is going to be, how does my function negative x minus 1 is going to look like? So if I want to know how this going to look like, all I have to do is, as suggested over here, so I'm going to reflect my function f of x over the x-axis. So let's highlight what is the x-axis. So this is where the x-axis is. So I'm going to pretend like there's a mirror right there. Okay, so that is going to be my mirror. And now I'm going to start sketching and reflecting them. Okay, so what happened is that for this function right here, so when I reflect that on the x-axis, so this is how the function looks like. And let me elongate my axis a little bit because I need it to be a bit longer, stretch to the bottom. And for the rest of the function, so which I were to referring to this until here, so what happened is that when I reflect that, so on the x-axis, so this is how my function is going to look like. So you're going to sort of like pretend that the x-axis is going to be a mirror, and whatever that you get is going to be the reflection from the mirror. Okay, so that is how the function looks like. That is what happened. So when your function transform from f of x to negative f of x, so that is how it goes. That will be the idea. Okay, and then next, so we have the case of f of negative x. So what happened is that if your function start from f of x and it's been transformed to f of negative x, so the function, the graph is going to be reflected over the y-axis. So this one, negative outside, is going to be over x-axis. When the negative is inside, it's going to be over the y-axis. So what is the difference between the negative inside and outside? It's going to be something like this. So for example, let's say if I have a function f of x, which is equal x plus 1. So if I were to change this to f of negative x, what happens is that whenever I come across x, so this will be transformed to negative of x. So that is why this is going to be negative x plus 1. So that will be the idea. Or if I have a quadratic, so f of x is going to equal x squared plus 2x plus 1. So if I change this to f of negative x, it will be a similar idea. Now all the x is going to be transformed. So here I will end up with, so be careful with the power is outside. So it's going to be negative x to the power of 2. So plus 2 multiplied by negative x plus 1. So this is going to be x squared minus 2x plus 1. So that is going to be the function f of negative x. So let me show you an example. How is it transformed? Okay, let's say if I have a function quadratic for now. So let's say if I have f of x is going to equal x squared plus 2x. So when I sketch this, my function is going to look something like this. So f of x equal x plus 1. No, I don't need it to be like that. So let me sketch the axis again. So let's say it's going to be somewhat like this, okay? And in terms of this is going to be a is greater than 1. So therefore, so I can actually write this as x plus 1 square minus 1. So my minimum point, so you can calculate this for yourself using the formula that I've introduced in 2.2. So the minimum point is going to be -1, -1. So let's say -1 is going to be somewhere over here. So -1, -1. So this is going to be the minimum point. And here, my intercept point is going to be at 0. So if I were to sketch, so this is somehow going to look something like this. Oh, that's hideous. Okay, so I think it looked better now. So somewhat it's going to look like this. Okay, so the intercept is going to be at 0. So now what happens is that I'm going to transform this function. Okay, so I'm going to transform this function. It become f of a negative of x. So my new function is going to be negative x to the power of 2. So plus 2 multiplied by negative x. So it's going to be x squared minus 2x. So how does the graph of x squared minus 2x looks like? So according to the rule that we have over here, so if a graph transforms from f of x to f of negative x, we're going to have to reflect that over the y-axis, over the vertical axis. So where is my vertical axis? So this is going to be my vertical axis. Okay, it's going to be the y-axis or f of x axis and so on. Okay, now it's going to be the same idea. What you have to do is you have to pretend like this is going to be your mirror. Okay, this part, okay, when I reflect that, so it's going to look like this. Okay, and this part over here, so -1, -1 when I reflect, so it's going to be at -1, 1. So it's going to be 1 over here. It's going to be positive since it's on this side. So here it's going to look something like that, and it's going to go up here. So that is roughly how the graph looks like. So when I reflect this part over here, so it's going to be this, because the mirror is going to be right there. So this is going to be my mirror. So that is going to be the function. Okay, so that is the transformation from f of x to f of negative x. So these are like more example that you can have a look at. So when you reflect, so for the case of negative f of x, so if it reflects over the y-axis, so this is going to be, so let me put it like a bit thinner. So this is going to be our mirror. So it's going to be right there. So reflected, it's going to be up and bottom. So that is going to be the case when you have negative outside. But when you have negative inside, so this is where the mirror is going to be. So the reflection is going to be side by side. Okay, so next is going to be the translation when you have f of x plus or minus k. So here it could be like this. So you could either have f of x plus k, or you could also have f of x minus k. So what happened is that, so when you have f of x plus k, so your graph actually goes up k unit. When you have f of x minus k, so your graph actually goes down k units, right? So this is going to be the example. So the one in blue, so that is going to be my function f of x. That's my function in blue. So when I have f of x plus 3, so this means that, so this is in red, so my graph goes up 3 units. So this is what happened over here. So originally it is at this point, which is negative of 2. So it goes up 3 units. So we know that negative 2 plus 3, that is going to be 1. So this is going to be at 0.1. Okay, and as for the green one, what happened is that we start at point -2. It goes down 2 units, goes down 2 units. Okay, so therefore from -2 it's going to go down to -4. So that is what I mean by having f of x plus or minus. So how does the function looks like? So it's going to be something like this. For example, if I have f of x is equal x, so my function now, let's see if I have f of x plus 2. So this is going to equal f of x, which is going to equal x, and then I have 2 plus 2, right? So you just have to add 2 points from the original function, or -2. So that could happen as well. Okay, so let me clean this. But not that one though. So I'm going to clean here and this as well. Okay, other than that, let's just leave it there. Okay, and that is going to be like when the whole thing is being raised up and down. But for this one, only x in the bracket is being raised up and down. So what happened is that when your value of k is greater than 0, so it's going to be, for example, something like this. So if you have f of x plus 2, so what happened to your function is that the graph is going to be translate to the left k units. So if you have plus 2, so it's going to be to the left. And if you have k less than 0, so meaning that k is going to be a negative number, so it's going to be translate toward the right k units. So for example, you could have f of x minus 3, then we know that this is going to be translated to the right k units. For example, let's see if I have a function that looks like this. So if I have f of x equal x squared, okay, so if I change this function to f of x plus 2, what happened is that I'm going to have a function of, so it's going to be the same idea as before. Whenever I come across x, now it's going to be x plus 2, this is x, so my function is going to be x plus 2 squared. Or if I want it to become f of x minus 3, same idea as well. So here I have x minus 3, so here is going to be changed as well, so I'll end up with x minus 3 to the power of 2. Okay, so here because of this is minus, so it's been translated to the right 10 units, so 2 units. So that is why, for example, here, so the blue one, okay, let's see, it starts here. So when you translate it 2 units to the right, so it becomes that point, okay? And for this one, it translated 2 units to the left. So if I were to take this point right here, so the blue is the original one. So when I move it 2 units to the left, so it's going to end it up here. So that is what happened when you have x plus or minus. Remember, if it's a plus, you go left k units. If it's minus, so it's going to be you go right k units. Let me clean this. I don't want it to look messy for you. Okay, so I'm going to start with the example. So actually the solution is already there. Okay, suppose we have f of x is equal x squared. So we're going to sketch the following functions. So okay, so let's see now I started with a function of f of x is equal x squared. So I'm going to change this now. So I'm going to find what is going to be f of x is equal negative fx. So let's start with the basic one, which is f of x equal x squared. We know that f of x equal x squared, so it's going to look like this. So this is actually a graph of f of x equal x squared. Okay, and we know that what happened is that if you negative a function, so the function is going to be negative. So here it's going to be up here. So this is where all the f of x is greater than 0 or y greater than 0. But when you negative the function, it's going to be down here. So this is where f of x is less than 0. So that is why we know when we negative the function, so you have to reflect that over the x-axis. So that is why, so my new function is going to look like this. You just have to reflect that. So it's going to look like this. No, it has to be, what do you call that? The same size. So that is how my function is going to look like. So this is going to be f of x equal x squared, and this is going to be my function f of x equal negative x squared, because we know that when you negative the function, it's going to be negative of x squared. Right, so that is the first one. Okay, let's have a look at b. So what should I do for b? So b, it says that I have to make it into f of x plus 2. So now it's going to be f of x plus 2. So my new function is going to be f of x, which is equal x squared. So it's going to be x squared plus 2. So let's start with the original graph. So I know I'm going to need only until that. So this is my original graph. So this is going to be the graph of f of x equal x squared. And now I'm going to have to increase all of this by 2 units. I know that this is going to be a value of 0. So now instead of the value of 0, so I know that when I have plus 2, so my graph is supposed to go up by 2 units. So therefore 0, when it goes up 2 units, so this is going to be at 2. And this, for example, so it's going to go 2 units as well. So this line over here is going to go 2 units as well. So that's why my graph is somehow is going to look like this. Okay, so whatever that I had, it goes up 2 units. So this is going to be f of x equal x squared. So the one in green is going to be f of x equal x squared plus 2. So now my new intercept is going to be at 2. Okay, that's B. So now I have a look at C. C is going to be f of x plus 1. And this function is actually going to be, so I'm going to have f of x plus 1 is going to equal x plus 1 square. So which is going to be x squared plus 2x plus 1. So this is the graph that we wanted. And when we have f of x plus 1, I know that my graph, because of the plus 1 right here, it's going to shift 1 unit left or right. Because we have plus, it's going to be left. Shift 1 unit left. Okay, let's suppose this is going to be my function. And this is the original one. So this is my function f of x equal x squared. And I'm going to translate that. It's going to shift 1 unit to the left. So if I take this a value of 0, okay, so this is going to be no longer at 0. So this is going to be at 1. And where is going to be the new intercept? So previously, because of this, so I know that the intercept is going to be at 1, somewhere over here. This is going to be 1. So now I can sketch this. I have to shift it to the right. So therefore, my function is going to look somehow like this. No, that's too wide. Okay, so you can draw that prettier than I do. So basically, all you did is you shift all these lines 2 units towards the right. Okay, so that's what happened over here. Okay, so I even sketched this by using the software just to show you exactly what happens. Okay, so you shift like everything to the left of this one.